So lesson 73 has two concepts in it. One is factoring the difference between two squares. We talked about that in class today. And the other is another probability situation. So they're two completely different concepts, but I'm going to cover them both in this video. So factoring the difference between two squares, and then we'll get into the probability. So difference, as we know, is the term used when you subtract two terms from each other. And we've been factoring trinomials, something such as x squared plus 4x plus 4. That's where we put the two parentheses. We look and put an x in each one. We look for two numbers that when multiplied together equal 4 and when added together equal 4. In this case, it's plus 2 plus 2. That is that these two terms in parentheses are factors of this trinomial. Now, we can also do factoring the difference of two squares. So for example, if we have 9m squared minus 49, we can notice that this looks different. This is a trinomial, meaning it has three terms. This only has two. So we have to do something a little bit different when we factor it. We can do this, we can factor this because it has a unique situation. Each of these terms, 9m squared and 49, are perfect squares. That means that they have two numbers when multiplied by each other. A number when multiplied by itself will equal this, and the same as with this term. So when we look at this, we do the same thing with our parentheses. We look for the square root of this term. The square root of 9m squared is 3m. So we're going to put that right here. It's 3m times 3m. 3m multiplied by itself equals 9m squared. That's what makes 9m squared a perfect square. So we're going to put 3m first in both of these parentheses. Now we look at the second term, which is 49. 7 times 7 is 49. So 7 multiplied by itself equals 49, which is what makes 49 a perfect square. Now what do we do with that? Well, we're going to add 7 in this parentheses, and we're going to subtract 7 from this parentheses. These two terms are called conjugates. And what that means is that if you add them together, the conjugate of it is subtracting it from each other. And let's see why that works. So this would be your answer after you would factor 9m squared minus 49. Let's see why that works. When you do the distributive property, we get 3m times 3m, which is 9m squared, and then 3m times minus 7, which is minus 21m. Now we do this. 7 times 3m is plus 21m, and plus 7 times minus 7 is minus 49. When you look right here, negative 21m plus 21m, they cancel each other out, which leaves you just with what we started out with, 9m squared minus 49. So that's why when you factor the difference, it only works when they're subtracted from each other. It would not work if they were added together. But when you have a difference of two squares, you can factor it into its conjugates. Let's try one more to make sure that you got it. So let's try one that's a little more difficult. I have negative 36 x to the 6th, y to the 4th, plus 49 a squared. The first thing that we notice is this is not written in this form. This is written as an addition problem with a negative term in front. We need to switch these around. We need to write it as a difference of two squares. So we will write it as 49a squared minus 36 x to the 6th, y to the 4th. Now we see that these are two squares, two perfect squares being subtracted from each other. So now we can just simply write the conjugates of the square roots of these. What I mean by that is we look at this first one, 49a squared. 7a times 7a equals 49a squared. That's a perfect square. So we write that in the first part of the parentheses. Now we look at this one, 36 x to the 6th, y to the 4th. The square root of that would be we're going to add it on this side, 6x to the third y squared. Because 6x to the third y squared times 6x to the third y squared, we times the 36, 6 times the 6, and we get 36. X cubed times x cubed equals x6 because we add the exponents. Y squared times y squared equals y to the fourth. Again, adding the exponents. So that is the square root. 6x cubed y squared is the square root of this. When we write the conjugates, we add it together in the first set of parentheses. We subtract it in the second set of parentheses. So when you factor 49a squared minus 36x to the 6, y to the 4th, this is your answer right here. Okay, so we're going to move on to the probability part of this chapter. We're talking about probability again. If you remember, probability has on the top part of the fraction, the number of desired outcomes, and the bottom part of the fraction is the total possible outcomes. So the thing that's a little bit different about the probability in this chapter is called replacement. And what I mean by that is, if we have a bag that has 3 black marbles and 5 white marbles, they want to know that they're going to draw 1 marble out of the bag first and then put it back in. And then a second marble we're going to draw out. So we want to know, what is the probability that both marbles will be black? So we're going to see what's the probability of pulling out 2 black marbles? Okay, so to find the probability, the first time that we reach our hand into the bag, the chances of pulling out a black would be 3, because there's 3 black marbles, out of a total possible of 8. There are 8 marbles in the bag, so it would be 3 out of 8. That's the probability of the first time we would draw a marble. The second time we would draw a marble, so we're going to multiply it. If we put that black marble back in, if we put whatever marble we take out, then the probability is the same. It's 3 out of 8, which means the possibility of drawing 2 marbles that are both black, as long as we replace the first one, would be 9 out of 64. Okay, so now there's a different set of problems. Let's say we do this same probability problem again, only this time when we pull the first marble out, we don't put it back in the bag. So the probability of drawing 2 blacks in a row in that case is different, because the first time that you put your hand in the bag, the chances of pulling out a black marble is still 3 out of 8. But if we don't put that marble back in, whatever marble we choose, then the second one is, if the first one that we pulled out was a black marble, and we leave it out of the bag, the second time that we put our hand in the bag, there are only 2 black marbles left. So the top part of this fraction would be 2. And if we didn't replace that first black marble, that would leave a total of 7 marbles in the bag. So the first time would be 3 out of 8. Second time would be 2 out of 7. And so that leaves us the probability of 6/56. But remember, we cannot leave this fraction unsimplified. We must simplify that. So both the numerator and the denominator can be divided by 2. So then that becomes 3/28. So the probability of pulling out 2 black marbles if we do not replace the first one is 3 out of 28. I just want to make sure you see the difference. The difference comes in this second fraction. It is still 3 out of 8 here because we have the same number of marbles the second time. It becomes 2 out of 7 because we have 1 less black marble left and we have 1 less marble in the bag.